Let us look at proposition number 4 of book 8 of Euclid's Elements. The proposition says, given as many ratios as we please in least numbers, to find numbers in continued proportion which are the least in the given ratios. So we are given A is to B, C is to D, E is to F ratios in least numbers. So we are given these three ratios. What we have to do is find HGKL such that they are in continued proportion with A is to B, C is to D, and E is to F ratios. So let's see how we can do that. Basically, these ratios are different. In the previous propositions, we were talking of numbers in continued proportion in constant ratio. Now the ratios are different. So first thing we do is we take the LCM of B and C and then we incorporate this LCM. So let A measures H. A measures H as many times as B measures G. So here we are incorporating G. Now let B measures K. B measures K as many times as C measures G. Now once we do that, E will either measure K or it will not. Remember, A, B, C, D, A is to B, C is to D, we have done. Now we have to make sure about E is to F. So either E will measure K or it does not. So which means we have to take two paths now. One where we take that E measures K, and in the other path, we look at E does not measure K. So let us say E measures K. Let's bring it in. E measures K. Let F measure L as many times as E measures K. So based on whatever we have done till now, what are the proportions that we have? We have A is to B as H is to G. Similarly, we have C is to D. Because I said A is to B, you might be tempted to go for D is to C. But the ratio that we are interested in is C is to D. So C is to D as G is to K. So that is another proportion we have. And because of this, we have E is to F as K is to L. So we have arrived at the continuous proportion. H, G, K, L are in continuous proportion in the ratio of A is to B, C is to D, and E is to F. Now, we have to prove that HGKL are the least such numbers. Assume that HGKL are not the least numbers. Means there has to be some other set of numbers. So let us say those numbers are NOMP, the least such numbers. So if we assume that NOMP are the least such numbers which are in these ratios and in continuous proportion, that means A is to B is equal to N is to O. A is to B are the least numbers forming a ratio, because remember these ratios are given in least numbers. So which means what? That B measures O because of this proportionality. Similarly, C is to D is equal to O is to M. That means C measures O. Now based on these two, we have B and C measure O. Two numbers measure a number. That means what? Their LCM will also measure that number. So LCM is G of B and C. So G also measures O, which is clearly not possible. Why? Because G is greater than O. So which means HGKL are in continued proportion with A is to B, C is to D, and E is to F ratios, and these are the least such numbers. So this was our first part. The second part is when E does not measure K. So let's see how we can prove this in this case. When E does not measure K, so we take the LCM. So when A is to B and C is to D, they are not the same ratios. We take the LCM of B and C. Now, basically this case is saying that C is to D is not equal to E is to F. They are different ratios. And we have said E does not measure K. So LCM of E and K we are going to take. So now let H measure N as many times as K measures M. Let G measures O as many times as K measures M. So here again, if you notice, we are incorporating the LCM of E and K. Let F measures P as many times as E measures M. Remember, we have H, we have G, and we have F. K we have, M we have, E we have. So basically these three steps are, finding NOP using these ratios, or rather these proportions. So what are these proportions now? H is to G as N is to O, because remember here K measures M, K measures M. So H is to N is equal to K is to M. G is to O equal to K is to M. So since K is to M is there in both of them, we can say H is to G as N is to O. Actually, it would be H is to N equal to G is to O. But then we can use alternately. We can say H is to G equal to N is to. H is to G is equal to A is to B. If we take it back, say here we have A measures H, B measures G. So A is to B is equal to H is to G. Now H is to G is there on both proportions. So that means A is to B is equal to N is to O. Now we have A is to B equal to N is to O. Now we look at C is to D. Okay, so let's bring in C is to D equal to what? Let's look at G. So G is a multiple of C, because G is the LCM of B and C. So G is a multiple of C. Yes. K is a multiple of D, since D measures K. That means we can say C measures O as many times as B measures M. So that means C is to D is equal to O is to M. C is to D came because G is a multiple of C and K is a multiple of. Now we have C is to D also. Now let's look at E is to F. Now E is to F is equal to M is to P, right? So E measures M. M is measured by E. So E measures M. So E. F measures P. So E is to F is equal to M is to. So we have all the three ratios, or rather 4 numbers in the ratios of A is to B, C is to D, and E is to F. So N, O, M, P are the numbers in continued ratios. Now we have to show that these are the least numbers, which means what? We assume that these are not the least and there are some other numbers that are in these ratios, which are the least. Let them be Q, R, S, T, be least such numbers. Okay. So that means what? A is to B is equal to Q is to R, C is to D is equal to R is to S, E is to F is equal to S is to P. That means B measures R, right? It also means A measures Q, but we are interested in B and R. So B measures R. Similarly, C measures R, since R is to S is equal to C is to D. That means B and C both measure R. B measures R, C measures R. So B and C measure R. Now we know LCM of B and C is equal to G would also measure R. C is to D is equal to G is to K. Where did this come? This came from the previous part of the of this proposition itself. We have seen that A is to B equal to G, H is to G, C is to D is equal to G is to K, and E is to F is equal to K is to F. So here if you notice, C is to D is equal to G is to C is to D is equal to R is to S. Since C is to D is in both these proportions, we can say G is to K is equal to R is to S. Or alternately, we can say G is to R is equal to K is to S. That means K also measures S. E is to F is equal to S is to T. So E also measures S. K also measures S. E also measures S. So E and K both measure S, which means LCM of E and K will also measure S. That is not possible. Why? Because N is greater than S. Therefore, N, O, M, P are the least numbers in continued proportion with these ratios. So that is proposition number 4 of book 8 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.